welcome. So the story behind this talk is very simple. It should have been a workshop. I submitted it as a workshop, and then somehow it ended up as a talk, which makes it much more fun. We will see how can we do in 75 minutes what you have been done through a couple of hours. That's the reason why we are talking in hours here. The good news are that I'm really optimistic that we are going to make it in 75 minutes. The pace will be fast, but we will be fine. So you're just after the lunch and want to sleep, so let's do a little bit of stretching. How many of you know Groovy? Okay, so I'm not sure how productive this session will be for you, because the idea is to learn Groovy. If you already know it, I'm very happy to have you here, but be prepared to a little bit Captain Obvious most of the time. For all the rest of you, many of you are not familiar with Java? Okay, so we're good. We're just perfect. A couple of words about me. My name is Baruch, and I'm developer advocate with company named JFrog. JBaruch and any possible social networks. I will be more than pleased to have any kind of feedback, question, discussion in any form from what you see on the screen. JFrog is a startup company based in Israel, California, and France. We are about 80 people, and we have two products, which both of them are very, very related to Groovy. We are also obsessed with frogs, so we have like frogs everywhere. We have a thing for frogs. We also have a booth here with stress relief frogs, frog t-shirts, frog pins, and everything like, okay. We have two products. One of them Artifactory, which is a binary repository. It's a little bit like the one that you have advertisement on your desk, but the good one, right? And the other one is a distribution platform named Bintray. And Bintray, both those products give a lot of love for Groovy. In Artifactory, you write your user plugins in Groovy. Bintray itself, written a very large chunk of it, written in Grails. All the service that you see is Grails, which basically means Groovy. Groovy is hosted on Bintray. When you're going to download Groovy, you download it from Bintray, and Groovy is developed with Artifactory. So development process is based on Artifactory as a binary repository. Really a love story between JFrog and Groovy. A little bit about why I think that I can stand here and tell you about Groovy. So last week, Cedric Champeau, which is one of the key people in the Groovy team, published a blog post which was about to convince you that after the cease of sponsorship of Groovy language with Pivotal, the language will go on. And the main idea of this blog is community contribution is what's made Groovy what it is today, and since the community not going anywhere, Groovy will continue to exist. My humble contribution to Groovy language is listed here. I just search and find myself mentioned 3 times in this blog, and I think that that's the reason I can stand here and talk about Groovy. Okay, now let's make this session like very, very short, and you will have plenty of time for coffee. Just go and read this book. And that's all. Thank you very much. No, okay, I'm just kidding. But this book is what you need. Actually, I'm not kidding. This is the best resource you can grab to learn about Groovy. It's written by half a dozen of very, very important folks in the Groovy community, starting with Guillaume Laforge, with the project lead of Groovy, Cedric Champeau, as I mentioned, one of the key people in writing Groovy language, Dr. Paul King, who is the top contributor to Groovy language since the day one until today, more than the people that were actually paid to write Groovy language, etc., etc. It's still in the early access of Manning, but it was shipped for printing 2 weeks ago or so, so it is actually a release already. You can still buy it in the, as a early access on Manning's site, but I believe it will hit Amazon and everything else in the following days. Okay, so we will continue for a while, but anything you will see here, it's just have one mission, to make you read the book. Okay, because it's actually we have very limited amount of time and a lot of code. Okay? So this is it. Yeah, and still, and since I'm very pushing this book, I stole most of the examples and the diagrams and everything from this book without feeling bad about it. Okay, so let's chase. Let's get to the business since we don't have much time. I will do this presentation in 2 phases. First one will be like a real the feel of Groovy. I will give you a couple of examples of what the Groovy feels like, and then we will get to a little bit more details on the key features. But of course, it's all it will all be like very, very tip of the iceberg. Yeah, so maybe you know this very nice cartoon. It's about how to learn C++ in 21 days. It's a lot of text, so I will give you the bottom line. You need to learn for, you know, many years, and then invent in time machine, go back 21 days after you started, and kill yourself and replace yourself with the future you. This is the only way you can learn C++ in 21 days. With Groovy, this is not the case. With Groovy, it's not the case because Groovy is a unique language in terms of the positioning in this diagram of feature richness versus Java friendly. So we have a bunch of other languages which can be very, very feature rich, but look and feel nothing like Java, and actually your Java experience won't help you a bit. I can name Clojure, for example, which is very, very powerful language, extremely powerful. But you look at the code and all you see are parentheses. Okay? It's kind of hard. Other example is a language which very, very similar to Java, but we have issues with it in terms of how feature-rich it is. And maybe I will mention one of them, Java. Right? So it's very easy for you to learn Java because you know Java, but you didn't get anything new. Groovy is positioned uniquely because it's extremely feature-rich, and I would say, you know, the most popular and talked about language on the JVM those days is, of course, Scala. And, you know, Scala can do that, and Scala can do that, and it's both object-oriented and functional, and they have this wonderful concurrency model of actors, and it has traits, and everything very, very, a lot of hype about Scala. I would say that Groovy has the same features, and even more, because it's also being a dynamic or a static language, you choose, and it feels and looks like Java. And I would say that the only reason that Groovy is now have less hype about it than the other languages, it's a purely marketing and public relationship issue. By the way, it's not less popular than Scala, because if you check the TIOB language, it's consistently rated higher than Scala month after month after month. But that's okay, that's enough about Scala. So the thing is, Groovy, it's like more powerful brother and younger brother of Java. And this is what I mean. It has very, very tight integration with Java on every level. It starts with something basic like call Java libraries. A reason that you prefer a JVM language is that you can use all the Java libraries that I already have there. right? For example, Hibernate. I don't know if that's really the library that I want you to use, but you can use it, right? You can use it for any JVM language, from JRuby, from Clojure, from Jython, which is a Java JVM port of Python. And this port exists, so you can use Hibernate in it. Okay? So of course, this is like basics. And it goes all the way, calling from Java to those. Something which is not object-oriented cannot be called from Java. So Clojure is out, right, and Jython is out, etc. But Groovy is here. Inherit and mix. Groovy classes extend Java classes that extend Groovy classes, etc., all the way. No problem at all. Cross-compile. One compiler that compiles both of them, because otherwise it just won't compile because they have like cyclic dependencies one to another. Class substitution. Can I just switch the classes if they have the same fully qualified name? Will it work? The answer is yes. And this brings very, very simple IDE support, because if it feels like Java, looks like Java, probably the IDE support will follow, and that's true. We're going to talk about it in a second. And let's look at how syntax is similar. So this is Java, this is all you know. And this is Groovy. It's like Java, but without all the boilerplate. This is actually what you wanted to say here. It just took you much more symbols to say this. Right? This is, you can read, you can understand. It's purely, you should feel at home. And it goes like from here all the way Ruby, not very much, Scala, kind of back, but not so much. And then my favorite is, of course, Clojure, right? So very, very similar to Java and much more powerful. So Groovy enriches Java in 3 different aspects. First of all, the language itself. We will see today a bunch of new constructs, bunch of new syntax things that you can do with Groovy. This is one part. The other one is the GDK. GDK is a Groovy development kit. It has nothing to do with development kit. It's just a rephrase of JDK of Java. And when we say JDK, we actually don't mean the development kit. We mean the thousands of classes that Java gives us, right? All the packages inside the JDK. This is what we say when we mention JDK. So JDK enriches existence classes in Java. And we will see a couple of examples of that. So the same classes that we know and love with new methods. And one of them is, for example, a text method on a file that just returns you a string with the content of the file, right? It's something that shouldn't be there from the first place, and it's not there, and now it's there thanks to Groovy. This is very powerful. The other one, and the third piece of the puzzle are the libraries. The libraries are like the Java libraries, but they use unique features of Groovy. That's why they consider Groovy libraries and not Java libraries. All right? So this is about what Groovy brings to the table. And here, as I mentioned, a little bit of taste of Groovy, how it feels like. So here we have some variable number, and it's 0, and we create a file. This is like a pure Java construct, just without the import, because the import is there by default. And then we want to iterate over each and every line. And for every line, we want, wow, that was an eclipse. Not the IDE. And then we want to increment this number and print whatever in the line. This feels like fixed Java, right? So println, you don't need all the system out println. No semicolons in the end. No import of file, right? And here now this one is huge. This constructs the string without all the pluses between the different parts, right? This feels like Java as it should be done from the day one. And the output, of course, here will be first line, the second line, right? If this is what the file has in the first place. Another very nice features are the improvements of collections. So this looks like an array, but this is actually a list. This is how you construct list in Groovy. No new array list and then constant add. It feels like 5 lines to construct a list. The other option will be try to construct array on the fly and then convert it to list, which is going very, very awkward. This is what we want to do. This is a list of classes. And then you go like, I want to iterate over all the classes. And for each class, I want to print the package and the name. Right? So this is a pure for, no Groovy tricks, except of the usage of in here instead of the semicolon. This is readable for class in classes. Semicolon is for class, classes something. Right? So this is much more readable. And here is the amazing thing. Okay, so let's get here for a second. There is no public field package in the class. There is a method, get package. But when you actually write get package, you actually mean give me the property package. So just write it that way. Okay? And the same with get name. This is get name, but that's okay. This is what I want to write actually, without the boilerplate. So that's the same idea. We will get to all the implementation details, don't worry. Okay, this is like a teaser, only a teaser. Or even better, here is the same list, and then I go .package.name. Wow, what happened here? We are trying to get a property named package on a list. There is no property package on a list. There is no method get package on the list, and there is no public field package on the list. So what Groovy will do? He will take the extra step for you. He'll say, okay, there is no property package on the list, but maybe there is a property package on each and every of the members of the list. And this is what will happen. And then get name. Right? So instead of nagging you, oh, you forgot the semicolon here, go put it because I cannot do it for you. Groovy takes the extra step for you. It tries to get what your intention is and execute that. Okay, so of course, if I would use something that list has, for example, size, it will call size on the list instead of calling size on the members, but there are ways to overcome that as well. Okay, so this is one of my favorites. Whoever did XML data processing in Java? Who enjoyed it? Right. There is a simple XML which has customers, corporate, and then a customer with attributes of name and company. Okay? And this is how it processed with Java. XML Slarper, this is the guy, with Groovy, this is the guy that's going to take care of it. Parse, I'm parsing the file. And here I get something that's called customers. It's probably some kind of XML node something, but I don't want to know. What I want to know is that customers is a list, so I can iterate on it. And each customer inside has attribute name and attribute company. So this is what I'm going to get for 3 lines of code. One of them is opening a file. Right? So this is something else from what you know and love from XML processing in Java. Okay, so enough with the teasing. Let's now go and talk about the real thing. So first question is, you are going to download Groovy. You can do it through your through Groovy official website. They have a new one, very cool one. Or you can go directly to Bintray and download it from there. And then you have 2 options. You have something called distributions and something called, this is the Maven repository, which basically mean modules. So Groovy distributed in 2 distinguished ways. For each and every version, you might download the executable file, the installer, and there are installers for all the major platforms, or you can have a bunch of jar files. And the question is, when you select what? So the distribution, the installer, installs Groovy as it was like the JDK. Okay? It has all the executables for running Groovy, compiling Groovy, etc., etc. And if you are going to create your new Groovy project, distribution is what you need. And we are going to talk a little bit about the files that we have there. The separate jars, the modules, are your pick when you want to embed Groovy in the existing Java project. So I'll take our example, Artifactory. Artifactory written in Java. But we do need Groovy support for the user plugins. So for that, we will just add Groovy as dependency to our product, and it will be downloaded with the correct jars, and we will be able to execute Groovy code inside our Java application. Okay, so those are the differences. So of course, the interesting part here when you start a project from scratch, being it Hello World or whatever, are the distributions. So in distribution, you have this bin folder with all the binaries, and again, it should feel exactly like installing Java, JDK. And here we have a lot of files. Some of them are interesting, some of them less. The most interesting ones are Groovy. Groovy gets an argument which is a string and executes this string. So you can write a piece of code and it will be executed. The other one is Groovy C. Groovy C creates Java classes, compiled Java classes, actually it's JVM classes, out of Groovy and Java code. So when you want to wrap your Groovy application as a jar file or as a WAR file and deploy it or distribute it or do whatever you like with that, you will compile it with Groovy C. Of course, you won't do it manually. You will use a build tool for that, or at least an IDE, but this is what is used behind the scenes. Groovy doc, similar as Java doc, knows how to create a documentation for your Groovy classes, and Groovy SH starts a Groovy shell in which you can type stuff and do your, just more than one string as it was in Groovy. The one that I didn't mention is the Groovy console, and I would like to give it a little bit more love because this is actually the only thing that you might use directly from this bin folder. Groovy C, choose from your IDE. Your IDE will probably know how to run, your Groovy snippets, so you won't need not Groovy nor Groovy SH. Groovy doc is also a part of the build. Groovy console pops up a very nice Swing UI in which you can type some Groovy code, execute it, and the most interesting part, you can analyze the abstract syntax tree of this code. This is kind of a little bit advanced feature. I will show a screenshot of Groovy console, and this is something that you might to look at and of course read more about it. IDE support. So as I already mentioned, being so close to Java gives very easy path to implement very good Groovy support in all the major IDEs. So from Pivotal, they have something called the STS, and that's the Spring Toolsuit, and a fork of it, which is the GGTS, Groovy and Grails Toolsuit, and this is it. This is like the official IDE for Groovy and Grails. For those of you who love Eclipse, they will probably feel at home. If you ask me, I would definitely recommend IntelliJ IDEA for any given time over any flavor of Eclipse. And the best, again, I'm a little bit biased, but I found that the best Groovy and Grails support is actually not in the official IDE, but in IntelliJ. And NetBeans has very good Groovy support as well. Whoever used to NetBeans won't feel uncomfortable with Groovy as well. Yeah, so Maven it's a build tool, it's not an IDE. And of course, any major build tools can deal with Groovy very well. Maven has very good Groovy plugin. You just know how to compile Groovy and Java together. And of course, Gradle, which is written in Groovy, has great support for Groovy, and Ant with set of Groovy tasks as well. Okay, so this was like the introduction to how you do things with Groovy. Now let's start looking at the code. We have 50 minutes, we are good. Okay, so the most important thing is most of your Java code will be valid in Groovy without any alternations at all. You can take your Java code, rename the class file from being .java to .groovy, and chances are it will compile with Groovy compiler just fine. The semicolons and all the rest, the unnecessary imports and all the rest of the boilerplate, you can remove it, but it will work fine with it as well. There are some corner cases and some exceptions. So the first thing which is not supported are the anonymous inner classes, and that's because Groovy doesn't need it. Supporting it, it's a great deal of pain in terms of the syntax and the lexer, the abstract syntax tree, and the things that really only few guys understand, but it's a pain. And because Groovy has much more elegant way dealing with the job that we used to use anonymous inner class for, they are officially not supported. The other one is multiple initialization in a for loop. So if you can recall, when you create a for, in the part when you initialize variables, you can initialize number of them. Most of you don't even recall that this is an option. Whoever do can probably recall when they used it last, if at all. And again, supporting it is painful, so they get rid of it. Array creation with initialization, the standard Java way to create array and initialize it on the fly, is not supported because there are other more elegant ways to do it, and this guy conflicts with closures and stuff and everything. So again, it's not worth it. Java 8 syntax. Now this might be painful. How many of you already write Java 8? Yeah, a couple of hands. So we are still in the good shape, and we will catch up until most of you will use it. The thing is, first of all, because Java 8 has totally new syntax where it comes to lambda expressions, very significant changes in the Groovy syntax and the parsing of Groovy syntax need to be taken. And this is a major work that will probably be done with significant rewriting of a lot of Groovy internals, which is now done for Groovy 3. Hopefully Groovy 3 will be out this year, and it will definitely support Java 8. Groovy can run on Java 8 runtime as of today. You can take Java 8 JDK, Java 8 JVM, and run Groovy on it. It will run fine. What you cannot do is compile Lambda code in Groovy file. Another significant question is, how should it be taken care of? Should the Lambdas be converted to Groovy closures or not? They are very similar, but they are not the same. And with certain syntax, we assume certain semantics of behavior. When we write a Lambda, we know things about it. When we write closure, we know other things about closure. They are not exactly interchangeable, and we are going to talk about that as well, so that's a problem as well. Other than that, and okay, checked exceptions, we all hate them, so that's fine. Other than that, tries with resources. Try with resources is handled differently in Groovy. We have better way to deal with it. But there are corner cases when try with resources works and there is no special support in Groovy. And I would say personally that this is the only thing that I ever missed in Groovy syntax comparing to Java syntax. In the rare cases, when I come to the corner cases where there is no support for trying and resources in the Groovy way. For most of the things there are. So this is the list. I think it's rather small. All the rest will compile if you just rename your Java class to a Groovy class. Okay, so as I mentioned, Groovy is what Java should have been, with boilerplate as well. So when you write this in Java, you might up very well just writing that. So first of all, the import, you don't need it. The semicolons, you don't need it. And the parentheses, there are a lot of cases when you don't need them. Whether you put them or not for readability, that's a good question. A lot of things a lot of cases you'll prefer to have them, but they are not mandatory. Okay? So that's a good example of how shorter Groovy can be. Default imports is a big deal. How many times you import this Java util and think, come on, Java util, everybody use it, right? So you can say, okay, but I never do it. It's IDE stuff. I just use code completion and it gets populated and I don't care because I really don't see them because I can fold them, right? All those are dirty workaround about the simple fact that most of the widely used imports should be there by default. And this is how they are in Groovy. So all those are imported by default, no import needed, including big integer and big DSML from the math. Optional stuff. Return is optional. If a method doesn't have a return keyword in it, it will return on the last statement of the block. Dots even before method calls are sometimes can be skipped, and there is a whole chapter about writing in cells in the book that you already know you need to go and check. Type declarations are optional. You can say, I know what this type is and I want you, the reader, to know it. Or you can say, it's something. Let's see what it will become down the road. Typecasts are optional as well. You can cast one object to any type without any, pairs of parentheses around them. And they either will work in runtime or won't work in runtime. And that's exactly as it is in Java. Java insists that you will confirm your intention to cast something, when I'm talking about downcast, which cannot be verified at compile time by adding the explicit cast. In Groovy, probably you know what you are doing. Another very nice improvement, for example, is the assert. So this is how assert looks in Groovy. First of all, who know that there is assert keyword in Java? Okay, most of you know. Who know that this assert word is not on by default? Right? Couple of hands. It's not on by default, which means that you can do whatever, assert whatever you like, and then you run your code and they're all ignored. Because assertions are not fortified, are not enforced by default in Java. There is a flag that you need to turn on, which is kind of stupid because if I have this assert, I intend it to be checked, right? This is something that I want to check. Well, it's not. In Groovy, assert is turned on by default, which means that it's an important tool. In Java, when you have assert and it falls, you just get an assertion error without any valuable information. In Groovy, when assert falls, this is how it looks like. You have the exact picture of what went wrong. So you have this. This is what we got, and this is how we sum up, and this assertion is false. We will get to that as well. Classes are also very nice in Groovy, of course much nicer than in Java. So first of all, the class is public by default. When was the last time you write a class which wasn't public? No, I will rephrase it. How many of you used it more like once in, I don't know, 50 times that you use a public class? Public should be, for classes, should be the default, and it is. And here is a class which looks a lot like Java. We have a private field and the constructor and the getter, right? It looks like Java for most of the part. But it can be better. I already mentioned properties, and here they are again. So what we have here is the same class, but instead of having a private field and the pair of getter and setter, now I have a property. It looks like a field without any access modifier, and it doesn't make it. What is the default in Java without modifier? Package friendly, local, whatever. Whoever used it? Yeah, right? Not very usable default. In Groovy, if you don't specify a class access modifier for a field, it will become a property. Property means that it will do whatever you expect it, and this is, by the way, you remember the Groovy console? This is the Groovy console. Groovy console allows me to see the code that Groovy will generate when it goes to the Java class file. So here we go, and look here. Get title and set title. Those guys are generated, and up there is a private field title as well. So when Groovy sees property, it goes like, okay, this is what the Java folks have to write like half a page of source code for it. Private field, getter, setter. Private field, getter, setter. And here I hear a lot, yeah, but we don't do it manually. IDE does it for us, and we can even hide it and collapse it, and we never feel that it's there. Again, this is the real thing. This is the source that you need to maintain. This is how it looks. This is how it reads. Much more powerful and elegant, right? And of course, you can rely on it, or you can override it. If you don't want to use it, this works as well. Once you have a field which is private, no getters and setters will be generated for it, and you are welcome to do it yourself. Or if you do have property, but you want to do an additional check in the setter, you can just go and write a setter. And of course, if there is a setter already implemented, Groovy won't generate another one or won't override yours. So it gives you the basics. It's like a convention, and then you can go and override it with whatever you like, right? Scripts. This is something also very, very powerful. I don't know, I have this story from when I started to learn Java. It was, I think, 1998. And the first lesson was extremely painful. Because I would say, just sit here and, like a monkey, copy a bunch of gibberish from the screen to your notepad, and it went like class, blah, 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 public static void main, system out, blah, 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 hello world. Right? 90% of this didn't make any sense until the very late. Object-oriented, static context, you know, when it becomes clear whatever this static, public static void main means. Not in day one. And that's because we don't have any mean to write a script in Java. But we can write script in Groovy, and it's not magic. It's just a syntactic sugar over what you already know. So it works very simple. Class is created for a script. Whatever code is written in the top level of this file is wrapped in the main method. And all the rest is used as it was normal code. The methods that we write in scripts will become methods of this generated class. The classes that we have in the script will behave like normal classes, and everything will work as expected. And here is an example. This is our class with the property, right? This is all what it takes to write a fully blown Java class with properties in Groovy. And then we have here some code that creates a class. And this is a very nice feature. It's called the name constructor. You know what happens? You have a constructor with 20 strings, and you have no idea which one should be which. Whether the first name and the last name, or it's a surname, it's a given name, and then it might be the other way around, right? It's not very clear. In Groovy, thanks to the very easy way of creating maps, and we're going to get to it, it's very easy to create named constructors. More so, as you can see, it's not here, which means it is generated together with the getter setter of a certain property. And then we go, get title works, and method call works when this method is actually in the script, right? So once again, this goes to the main method of the generated class. This goes as another method of this generated class, and this is just another class. Okay? This is how scripts work. This is very easy and very powerful way of scripting something, and this is something that I find myself using very, very often every now and then when I need to write some code. Okay? Does it make sense? Annotations are mostly the same as Java. The concept is the same, but they are much more powerful in usage. Annotations are metadata. They cannot be very powerful or unpowerful. It's just something that we tell about our code. The usage of this metadata is what makes this metadata useful or less useful. So with Groovy, annotations have very, very useful, concept. Because of that, they can also appear on unexpected places. For example, in Groovy, it is allowed to put an annotation on the import statement, just for you to understand, and you will see now why. So this is an example of very serious usage of annotation. So I have this class again, the same course class, and I annotated with immutable. What I'm going to have is, if I look in the console and open the generated code, a fully blown immutable Java bean, right? With all the correct immutable behavior taken care of, like the fields is final, the class is final, I have protective copies for all the mutable fields that I use, etc., etc. Everything works as expected by using this annotation. And that's because there is a very simple way to process those annotations when the code is being compiled. And then we can do stuff with it. More so, it's also very, very simple for you to add new annotations and then enforce checks and enrich your code when you are building stuff with Groovy. And there are a lot of them. ToStrings adds a very nice ToString implementation instead of you going and implementing ToString for yourself. Equals and hashcode adds equals and hashcode with an implementation that makes sense. Tuple constructor, this is the constructor that I showed you earlier that creates like a name constructor stuff. Canonical creates a Java bean. Canonical, it's like it should be. Okay, so it will create all the constructors, getter, etc., equals and hashcode, whatever Java bean should be looked like. Lazy, you can put this lazy annotation on a field and it won't be initialized until it is firstly called. And that may be a big difference. Index property, you can have your properties to be indexed and then you can access them by index. Inherit constructors. Now this is something you all should be very easily connected to, right? In Java, you don't inherit constructors and then you go and implement them over and over again. And here again, I never do it, IDE does it, but still I don't want to do it. Inherit constructors solve this problem as well. Delegate. You implemented a delegate once or twice in your life. Not a very nice task to do. You need to repeat all the methods from the object, which is a delegate in your class. At delegate, you put it on the field, and boom, all the methods of this property appear in your class as well, and you can just call them. Singleton, you know, anti-pattern, don't use it, but if you have to, add singleton on the class level will provide you with get instance, safe creation, and other needed things. Immutable we already saw. It's like the canonical, but it creates immutable object, and batch of logger annotations that will inject a logger instance for you and will configure the correct category by using the name of the class. Again, it probably will save you like a long line of code in each and every class, but it's a long line of code in each and every class. Synchronized with read lock, with write lock, bunch of AST transformation that will allow you to write concurrent code. But in Groovy, there is a very powerful library named gparse, And I will repeat myself again. I believe that it's much more powerful than, for example, actors of akka, which provide you with a high-level serialization facilities that will allow you to write concurrent code in a very safe, simple, and understandable way. So instead of using low-level constructs, you can use gpar as well, instead, and that's a good thing to do. Okay? And we are not done yet. Autoclone will implement clonable in the correct way, and there are a bunch of ways to do it. Auto-externalize will implement externalizable in the correct way. Package scope, all right. So sometimes you do need this package friendly. How do you do it? You cannot leave the access modifier out. It will create a property instead. And there is no keyword for package friendly, none in Java, none in Groovy. So you can just annotate it with the page scope, AST transformation, and it will do the job for you. Category and mixing are the ways to actually mix behavior of one class to another that will allow you something like the default methods on interfaces in Java 8, but in much more elegant way. Okay, here is another one, grab. As I mentioned, I can put it on an import, and this will actually create a full dependency management for you. So now here I use class utils that comes from commands lang. I don't have class utils anywhere in my class path, but I don't need to. I just can annotate an import of the class which is unavailable, and boom, it will become available. Groovy will go to JCenter, to Bintray, download the needed jars, put it in your class path, and everything will work. Right? This is especially handy in scripts when you don't have a full build. You don't have Maven, you don't have Gradle, you don't have Ivy. You just want to write a couple of lines of script, but you still want to use some library. This is a very elegant and simple way to do it. Okay, GStrings. GStrings, you already saw an example, is the special kind of string that allow you concatenation of strings without the endless quotes and pluses in between all of them. So you just mark whatever should be resolved as a variable with a $sign, and everything will be built as a one string. Now the strings are final and immutable, and Groovy don't mix GStrings with strings. So for strings you will use single quotes, and for GString you will use double quotes, and this is how can you distinguish between the two. Of course, strings are faster, so if you don't need this GString functionality, you can definitely stay with good and old strings like in Java. Okay, great support for regular expressions, and this is something I'm definitely not going to get into, because otherwise we really need like 4 hours. And we still have only 27 minutes. Now this is very interesting slide. Take a look at it for a second, and here you really start, you really need to start saying wow if you didn't already. So up until now, it's all good. This is probably primitive, and this is primitive as well. And then I plus one in another, and I get a result. And then boom, I invoke a method on a primitive. So how that happened? In a very simple way. In Groovy, everything is an object, at least as it looks to the user. Groovy will use a very heavy optimization with primitives under the hood. But whenever you deal with something, you deal with an object, so you can use methods. But if you use methods, and it means that our assumption that those primitives are primitives, this assumption is incorrect. It's definitely an object. How the hell plus works? In Java, you have either primitives with operations or objects with methods. In Groovy, you have both. And that's because everything is an object, but operators are just aliases for methods. So actually, when we write this, we are executing a method with a special name that is alias to plus on this attribute. And here is a table that gives you the most important ones. So plus, as you already guessed, is plus, and it is already overloaded in a lot of objects. Using curly brackets for getting to a value, this is something which can be achieved by overloading, by adding a get@at method, and this is how it works for list collections, etc., etc. Left shift are usually used for pushing something into something else, append or add, this kind of stuff. Switch is also overloaded, and that's kind of amazing, because if you have this isCase method implemented on your class, any class can be used in a switch, and not only whatever Oracle decides that you are deserved to use in a switch, right? Equals, this way actually calls equals. And that's a refreshing news that when you do equals, you get equals and not the same reference in memory, which doesn't mean anything, right? And this is a nice one. It looks like what? This looks like a flying saucer, right? And this operator is called a starship. And the starship operator is actually a simpler way to write compare to. And casting also can be used with an as keyword. Bottom line, you can just add a plus method in your class, and two objects of your class will be liable to be used with a plus operator. And this is like super cool, really. Okay, now let's talk about data structures in Groovy, which are powerful as list and map and comfortable as an array, right? Okay, so here is an example. This is a list, and it is dynamic. It's not an array. Although this looks like a creation of an array, it's actually not. The get looks like an array, but you already know the magic. Instead of this, what you will see in the bytecode is roman.getAt4. And getAt4, this is a normal method of a list that will return an object in the fifth position, right? This actually works. And here is the same. This is set at 8, and it behaves as it should. And this, as you can see, this is the confirmation that we are talking about a list and not an array, because we added a new entry here. Okay? And of course, all the rest of the normal list methods work. So size works, and you can use getAt and add, and everything will work as expected, but this works as well. With maps, it's even more fun. This is how you create a map. Compare it to how do you know you create a map. New hash map, boom. Put 10 lines of code. Instead of that, you can do just that. You have a key, semicolon, a colon, and the value. Beautiful, elegant, and here the getters work and the setters works in the same powerful and nice way. So HTTP 200, this now is a key that you want to get a value for, and HTTP with the key in the square brackets will add a new entry here, and all the methods of the maps work as well. This is very nice stuff. Now, this is something that you already saw when we spoke about those tuple constructors, the constructors that receive name and the value of this field. And this is exactly how they implement it, right? So, but this is not something into Groovy. You can definitely go and write a constructor for your Java class that will create a map, that will accept a map, right? And then in the constructor body, you will take this map, get the values by the names, and populate your state. The problem is not how to implement the constructor, the problem is how to use this constructor. Because without this simple map creation, you'll be in hell of creating maps, putting values to it, and then passing those maps to the constructors instead of just using it as is. So the problem is Without a simple creation of constructors, of maps, there is no way to use this neat functionality of named parameters in constructors themselves. Right? A new concept for you probably, you might heard a little bit about it in Java 8 Streams API. Those are ranges. And it's amazing how we didn't have ranges for years in any major programming language, because range is something that we think in, right? When we iterate through something, we think in range. We say, I want to get from number 0 to number 10 in my iteration, right? This is something natural. And instead, we write 4, which doesn't look anything like a range. And just because we are so used to it, our brain knows to understand, okay, this is actually a range. But in Groovy, you don't need this mental effort, because Groovy contains ranges out of the box. Here is how it works. I have a range from 1 to 10, and a bunch of methods that make sense for ranges, like contains, not contains, sizes, from, to, reverse, etc., etc. And the ranges can be anything. You can have your custom range of days in week, of sessions that you attend in a conference, on what's not. It's just so natural structure that it actually feels very good to have one. Right? So that was a little bit about that. 20 minutes. All right. Now we're going to talk about a very, very significant concept in Groovy, which, thanks God, Oracle, and others, we have already pretty close in Java as well. So Java 8, this you probably all know, whether you use Java 8 or not, have lambda expressions. And lambda expressions are the closest thing to closures that ever been in Java, and we will talk about the differences as well. So this is how it looks. This you already know. This is a list. And then there is a method on the list that's called each. And for this method, it receives a block of code that will be executed for each and every entry in this list. Right? So we actually passed here a block of code. And we are going to print it this way. So why do we need closures? First of all, we can reference to a block of code. And this is very important for handlers, listeners, callbacks, and all the other guys that you might know from JavaScript world, for example, but not from the Java world. And this is very interesting as well. Closures allow encapsulation of the control structure logic, and I understand that it means nothing to you, and that's good. We're going to talk about it in a second. Very important feature of closure, and that's why it's called closure, is that it encloses the scope of where it was declared, and you can access this scope as well. And yeah, it's not ugly comparing to, for example, anonymous inner classes. Yeah, so remember anonymous inner classes? Definitely, you definitely do remember anonymous inner classes. The idea of it is to be able to pass a logic that we have no knowledge of in advance to some API. And here is a classic example of anonymous inner class. But JButton add action listener, right? Add action listener, it gets an action listener A. And then somewhere deep inside the swing logic, this code will be triggered when some event happened, when button was pressed actually. When button was pressed, action performed will be called. And whatever logic there is written in this anonymous inner class action perform method, it will be executed, right? Closures serve the same target, but a little bit better. So what you can see here, it's actually pretty much the same. And the question is, and then the call is also pretty much the same. So if you ask me, I don't see big difference between this and this. Looks pretty much the same to me. And the question is, okay, so what's the big deal? The big deal is here, when you add, when you create this action listener. This is how it looks in Java. JButton, add action listener, new action listener. This is the anonymous inner class. This means that we have a class that has no name and it implements this action listener interface. And once it implements action listener interface, it has to override or to implement the action performed method. And here it goes. And it gets the event E. And also, so this is ugly. And also, I don't have much to do inside this method except of playing with this E, getting information from it, and that's more or less it. And this is how it looks in Groovy. JButton add action listener, and then a block of code which actually my intent. All this around, it's a lot of boilerplate that gives nothing to what I want to do. This is what I want to do, and I can do much. With Groovy, it's the other way around. No boilerplate at all. Add action listener, boom, my code, and from here I can access whatever I want from the caller of this code. This is very powerful. And now you should go like that, because that was looking very, very strange. And now we will take it step by step to understand what actually happens. So closure is an object. I can construct an object and pass it to a reference. This is a code that prints the word Groovy, and I can get a reference to this code. And of course, then I can declare a method that receives a closure. So here is an example. If add action listener was actually accessing a closure, this is how it would look. Closure action. And then, of course, I can pass a closure as an argument for this method, and here I go like JButton add action listener and pass this closure. Here, nothing strange. This is pure Java, right? And here's the trick. I can skip the reference altogether, all right? I just inline this action reference, and this is what I have. JButton add action listener, still the parentheses, and the sole parameter, which is a closure. So good so far. And for the matter of readability, so if I have here a lot of code, this closing parenthesis can go like 3 screens down, and I won't ever find what the hell this parenthesis is closing, right? So for the sake of readability, if the closure is the last statement as the last argument, I can put it outside. Okay? And then I just go, and here are my parentheses, and there is a one property, there is a one argument, I just put it outside of it, and then we can get rid of the parentheses as well, because actually we don't need parentheses. And this is the code which is by far more readable and gives me the intent right to my face instead of going around with all the boilerplate, right? So this is it. And now you can say, okay, you're a cheater. Add action listener doesn't accept closure, it accepts action listener. The thing is, I can cast my closure to whatever I like, to whatever interface I like, as long as the parameters match. So a closure that receives an action event can be cast and used instead of the interface that has one method, I don't care the name, but with the same parameter. So here I can write a closure. It receives one parameter action event, does something with that, and then I can cast it to action listener, and this will work because action listener has only one method and it receives action event, so it's very simple what should be called, right? This is kind of nice. Okay, so if you happen to attend some Java 8, I don't know, maybe a talk about lambda expressions, this looks very, very similar. In Java 8, you can write a lambda and then cast it to any, what they call SAM interface. SAM stands for Single Abstract Method Interface. Action Listener is such an example. It's an interface that has one method. And then you can cast lambda to it. And it's exactly what we just saw. Closures are more powerful because, first of all, in lambda, you have to have this interface for any lambda you write. You cannot write a lambda which is not backed up by any interface. In Groovy you can. We can cast it to any interface with even more than one method. We will need more than one closure, but we can take two closures and cast them together to an interface that has two methods, and they will be determined by the parameter types which closure represents which method. Also very, very powerful. And I already mentioned accessing to any variables, not only those which are final or even, how do they call it? Effectively final. So in Java 8, you can access from this lambda not only final variables, but effectively final variables. Those are variables which are final but not marked as final. Thank you very much. So in Groovy, you can access any variable. And of course, no parentheses, no semicolons, right? Okay, so this is how it works. We have a declarer of closure that actually creates a closure object, keeps it for itself. In later point of time, this declarer will call the method that might accept arguments and closure or just a closure as our example on the caller. Later on, this caller that now have this behavior saved will trigger this behavior in the right time. Okay? So when I write a button, I say I want this code to happen when someone clicks on the button. And this part will only happen when someone actually clicks on the button. Okay? This is how it works. All right, 10 minutes. Control statements. So control statements, and I already mentioned that with the encapsulation of I didn't mention it, by the way, right? The encapsulation of the stuff. Yeah, somehow it slipped. The most important reason for having closures is not having a for loop. This sounds very stupid because there is nothing scary in for loop. It's just a for loop. We can recognize one after our sleep. The problem with for loop is that it clearly states the logic of iteration on the collection. It goes one by one, which means that it cannot do what? It cannot do it in parallel. There is no way that this collection can be chunked to 2 and having 2 loops on top of that, and that's because we clearly stated we want a for loop. When we use closures, when we use lambdas, when we use methods like each, we encapsulate the logic of iteration. We just say, I want to call this piece of code for every object in my list. And do it whatever you like. You can go in the for loop, but also you can chunk it, do it in parallel. You can open a new thread for each and every member of the collection and do it there. Do whatever makes sense. But I don't care anymore how this collection got iterated. All I care is getting this work, which I pass you as a closure, done for each and every item of the collection. Right? This is the one and only reason why we have lambdas in Java now. For years, for decades, the Java language designers opposited the lambdas and closures. We don't want them in the language. They feel foreign for Java. But the death of the Moore law and the movement towards concurrency forced them to introduce lambdas, so Java would be able to encapsulate control statements and move forward through concurrency. Yeah, so control statements are a little bit like Java, of course, except of that. Look at this. Here you should go like, what? And we are going to talk about it in a second. Yeah, so for is a normal for, just using in instead of semicolons. And what else is here? And this is the each, right? So this is the each that I mentioned, which is a far better option than using the for. And the switch is a normal switch with a huge difference that you can use anything inside the switch and not only numbers and strings. Okay, you can do whatever you like. Now let's talk about this guy for a while. This is what it's called the Groovy truth. Groovy truth means that every object, no matter what it is, can be assessed for Boolean. Anything in the language will be true or false. And there is a decision table of how to do it. So Boolean, well, Boolean will be true if it's true. This is kind of simple. Matcher, regular expression, if the match is found. Collections and maps will be true if they are not empty, and of course not null, because object reference will be first checked if it's not null. String and GString not empty and not null. Number not 0. And you can add your own logic by implementing as Boolean method. So you can decide how your object will respond to an if check, whether it be true or false, based on whatever you have in your as Boolean method. And now this is amazing. How many times you wrote if a string not null or not empty? Like, I don't know, tons of times. You don't need it anymore. You just put a string inside an if, and you are guaranteed that the true will be only if it's not null and null empty. Very, very cool as well. Okay, 4 minutes. Wow. Dynamic Groovy or not dynamic Groovy? You know Groovy is dynamic language. The question is, what do they mean by that? So, and if Groovy is compiled and so close to Java, how can it even be dynamic? 2 ways of dynamicity in Groovy. One is the types. When I write def, what do I mean by that? Which type should it be? Or in terms of method dispatch. Method dispatch is not finalized, mean that I can write in my source code a call for a non-existing method, it will compile and it will run, and somewhere in the runtime, Groovy will decide whether it can find a method or not. And then it will call the method or fail. Optional typing, so dynamic typing in it's actual optional typing. When I write def, I mean is, you know what? I don't know what type is it. We will see down the road. And actually it means object in the bytecode, right? Def number is actually object number. And then it will be whatever it be. And it behaves exactly that way. And we have 2 approaches here. One, declare only when you have to. So during this presentation, you saw a lot of defs in the places where we already know the types. And there still were defs. So this is because I don't really care. The other approach is don't declare only when you have to. And this is a strange statement. When will I want not to know a type? And the answer is, of course, the type encapsulation. Again, we are here hiding something or not talking about something because we don't want to know what is it, right? And that's because you want to treat it like something else. So, and this is an example that you already saw. Here, the customer is some kind of ugly XML node or something, but I don't want to know it. I want to treat it like it was some person object or a customer object or what's not. And this has to do with ducks. This is dynamic. This is a duck typing which says, if I walk like a duck, swim like a duck, fly like a duck, and quack like a duck, who cares that I'm an XML node? Right? And then I have this customer, which I can cast to a customer, and it will work, although it is an XML node. And that's because I actively don't want to hear anything about any XML nodes in my code. This is a very good approach, and I definitely recommend that one, because when we have types in our code is much more readable. The other is dynamic method dispatch. And this is achieved by passing all the calls through a proxy. When Groovy calls to a method, it will never go directly to a method, because actually it might go to another method, or the method that I tried to call does not exist, and then Groovy will find the method that I intended to have, this kind of stuff. Decisions are making in runtime. And here is the same example again, right? So what happens here is that there is a no by method in an XML node. Trust me, there is not. But this will work because by the runtime, Groovy will already know that we don't care this method to be a XML node. Instead, we want to treat it like a customer, and the call to buy method in XML node will actually be a call to a customer buy method with the same state. Okay, and you are going to Google that. Those are the keywords: meta class, expander method class, method missing, property missing, get method and get property, and of course in the book you have them all. There are problems with dynamic approach. Beta assignment not enforced until the runtime, right? Bait types, and of course absence of method and properties will fall in runtime. For example, if I misspelled a method, it will only fall in runtime. So I can turn all this magic off altogether. I can enforce type checking by a type checked annotation, and I can turn altogether this proxy mechanism and actually create normal Java calls by annotating my code with the compile static. And then, of course, I will gain the performance of Java. And the question is, okay, I turn this off, so what do I have from Groovy? And the answer is, of course, still tons of synthetic sugar. All that I showed you, a simple way to create lists and maps, and everything works. And you can still turn it on when you need it. So when you have an XML slurper, say, okay, here I want the magic, and the magic will kick in, right? So it's actually a win-win, and this is why we love Groovy. Two last slides, just random things. Private scope is broken. In Groovy, you can access private variables from everything. And that's super cool. It's like, wow, it's one of the best features in Groovy. Because unit tests, of course, right? Unfortunately, they intend to fix it. I'm trying to convince them not to. We will see how it goes. Method can have default values. This is one cool as well. So here is the method string value, string encoding with default. And then overloading will be generated in the class, on the byte code, and I will be able to use print with value or print with value and another encoding. With is also nice. With gives you a context of an object. So you can have person with and then go first name, last name, and whatever you like without prefixing with person each and every time. Import aliases. You know, if you love Spring, as we all do, Gary, for example, you have those imports. Robot default impl factory bin implementation. Those, you can alias them as a very simple other class names. Refer method with string. This is also nice, right? This is a valid method name. Name can be method with spaces, and of course also with dynamic stuff. And this guy, I can get it, for example, from a user, from the UI. And then dispatch dynamic method in this way. Okay, tons of stuff we didn't cover. Most of the book we didn't cover. And go read that book. This one. Now, really, thank you very much.